Let's look at some special type of matrices. Now, let's say we have uh, a matrix A is equal to Aij, which is of order m by n. Okay. Then B, a matrix Bij of order n by m is called transpose of matrix A if Bji is equal to Aij, right? That means the rows become columns, columns becomes rows. So ith row, jth column becomes jth row, ith column. And the way we represent this is we say B is the transpose of A. Okay, very quick example. Let's say we have 3, 4, 5, 6, 7, 8. This is A. Then A prime or transpose of A would be 3, 4, 5, 6, 7, 8. So here you notice this is 2 by 3 and this is 3 by 2. Okay, based on this, let's look at theorems related to transpose matrices. If A be any matrix, then the transpose of the transpose of A would be equal to A. So basically when we take the transpose and then again we take transpose, we get back the original. Okay, so let's prove this. Let A is equal to Aij, which is of m by n order. Okay, then A prime would be Bji n by m matrix such that Bji is equal to Aij. And if we take the transpose of this, what would we get? Transpose of this. Then we will get Aij, which is again m by n, such that Aij is equal to Bji. So therefore, A prime of prime is equal to A. Okay, let's look at the next theorem. Now, the transpose of the sum of two matrices is the sum of their transposes. Basically, that means A plus B prime is equal to A transpose plus B transpose. So here, let's say A is equal to Aij and B is equal to Bij. Both are m by n. Now, there exists A plus B of order m by n. This is there, both m by n. We can add them, and when we add them, we will find a matrix which is also of m by n order. Now, which means we can find the transpose of that matrix, which is going to be of n by m matrix. Now, similarly, A prime is going to be a n by m matrix, and B prime is going to be a n by m matrix. Therefore, there exists the sum of these two transposes, which is also going to be n by m matrix. So, which means the order of A plus B prime is the same as that of A prime plus B prime, or transpose of A plus transpose of, right? So now we have shown that the order of this is same. Now what we have to show? We have to show that each element is also equal in each of these. So to do that, I comma j element of a plus b prime is equal to j comma ith element of a plus b. Why? Because they are transposes. So we just exchange I and j, row and column. Now, which means this is equal to AJI plus BJI. Again, we have just exchanged the values and we have added these two because this is A plus B. Okay, which basically implies that J comma ith element of A plus J comma ith element of B. Or if we exchange these values, what do we get? Ij, if we exchange it, we get I comma jth element of A prime plus I comma jth element of B prime. Okay. So combine these two as I comma jth element of A prime plus B prime. So basically all these steps imply I comma jth element of A plus B, I comma jth element of A plus B prime is equal to I comma jth element of A prime plus B prime. Since each of these corresponding elements are equal, therefore A plus B prime is equal to A prime plus B prime. Okay, and let's look at the next theorem. If A and B are two matrices or matrices such that they are conformable for multiplication, then AB prime is equal to B prime A prime. You notice that the order is reversed, right? Because matrix multiplication is not commutative. Okay, so let A is equal to Aij, which is of m by n order, and B is equal to, let's say, Bjk is of order n by P. So what does this conformable mean? So here you have m by n matrix and you have n by P matrix. So if these two are equal, then we say conformable matrices, conformable for multiplication. When we take the product AB is of order m by B, which means AB prime is of order P by M. Yes. Now A prime is equal to A, remember Ij is A. So this is going to be Ji of order n by M, and B prime is going to be Bkj. Here it is Jk. And this is going to be P by N, where Aj is equal to Aij and Bkj is equal to Bjk. Actually, what I should do is I should put it as this is going to be from the prime. This is going to be from the prime matrix, transpose matrix. Okay, which implies B prime A prime is possible since P by N, which is B, and N by M, here these two are equal. But A prime B prime is not possible since N by M and P by M. These two are not equal. So only this is possible. And this will be of order P by M. Yes, this is P by M. This is P by M. So AB dash, this AB dash, actually I should put it in a bracket because we are taking the product, transpose of the product. Okay. So transpose of the product order is equal to the B dash A dash order. Now what we have to prove is that the corresponding elements are equal. So A comma ith element of AB prime. See, here we said I comma K, but here we are talking of the transpose. So that is why K comma ith element of AB prime is equal to I comma Kth element of AB. So we start off from AB, and then when we finally we show that it is equal to A B prime A prime. Okay. So now I comma Kth element of AB can be written as J is equal to 1 to N A I J B J K, and this can be replaced with J is equal to 1 to N of A prime J I B prime K J, basically transpose of these two, which is equal to, again, sum of J is equal to 1 to N of B prime Kj, because this is going to be the multiplication of not the matrices but the elements, which is going to be normal rules of algebra, that is the product is commutative. So we can substitute it like this, we can exchange the positions like this. So Ji, which means that this is nothing but the K comma ith element of B prime A prime. You have to make sure that these two are equal, and remember the left hand side is K comma ith element of AB dash. So therefore all this implies that AB dash is equal to B dash A dash. Since we have said arbitrarily corresponding elements are equal to each other, it means that the matrices themselves are equal to each. And if you have noticed, to show that two matrices are equal, we have to prove two things. One is that the orders are equal, and the other is corresponding elements are equal. Okay, so that's it for today. Bye.